Hello class, welcome back. In this lesson we are going to discuss recursion. Have you ever asked yourself a question and not known the answer, but then you ask yourself a smaller question about that question that helps you lead you to the answer? That's what recursion is. Recursion is a method asking itself another question or calling itself in a recurring pattern that eventually leads to the answer. Let's take a look at recursion. Recursion. So as I mentioned, the name itself, recursion, means a recurring method call. So this is a recurring method call. In other words, it's a method that calls itself. So we're making a method call within the method of the same name. Why do we use this? Well, we use this because this is an alternative to loops. Think about what would happen when we call ourselves. We would end up going through the same logic again and again. So this is an alternative to loops. So the while loop, this can replace a while loop or a for loop in many instances. Recursion has a specific set of problems that it's really great at, and it's really good at problems that get smaller over time, that we can break down into smaller chunks. So it's great for problems that get smaller or can be broken down. We'll go over some examples in future lessons. One thing we need to remember is that much like the while loop, we need to create a base case, otherwise known as our stopping condition. So we need to form this, like any loop actually, but it's a great way to think of it like a while loop, in that a while loop you have to set this up. You have to be very specific, whereas for loops, this is set up in the header of the for loop. A while loop we have to be more specific. So this is more like a while loop in that we have to create our base case and our stopping condition. So how do we do this? Well, we're going to do this with an if statement. That is the basis of how we're going to stop, is generally using an if statement. And much like the while loop, inside the while loop we needed something to change in order for that stopping condition to happen. So we need an if statement and we need something to change in our method. Something needs to change. Okay, enough descriptions. Let's get into actually writing an example. So here we're going to write a simple example. And we're going to start with a void method. And we'll go ahead and call this recur. You'll often see this name in the AP exam, recur or recur1 or recur2. And we also need to pass in a value. Okay, so this method, I want this method to print out a series of numbers. And I actually want it to count up a series of numbers. So I'm going to write it a little bit backwards. So let's say we do this. We have system.out.println down at the bottom. And I'm just going to do a simple print. System.out.print, and let's print n and give it a little bit of space. So this would be fairly easy to trace. Anytime we call recur at this point, we would simply print out n with a space following it. We all know what that would do. So if I called recur several times within my code, I could print out on a line several different numbers, but I want recur to be able to print out a set of numbers automatically, and I want it to count up. So what would happen if I did this? Well, if I said recur of n, if I did this, what would happen? Well, if we think about it, it would keep calling recur over and over again. Before it got to the system.out to print line, it would call this method over and over and over again. As it gets into recur, it'd come here. And we'd create an infinite loop as it would go back and forth between calling itself. And we would get a term you may have heard in your Googling for answers and things, a stack overflow error. Stack overflow, meaning essentially and simply put that we've run out of memory. There's a more complicated answer to this, but that's what we can essentially think about. In this case, we have gone so far, it is an infinite loop, and this is essentially an infinite loop. Right? There's more nuance to it, but that's the easy way for us to think about this in recursion. So we need to avoid that. We need to change something here. See if I can erase this. There we go. So we want to change this so it doesn't just keep printing out n. Well, we can change that by changing what we pass into it. So we can say n minus 1. So now it's going to start counting down. But we still have a stack overflow error. Because even though we're changing n, we haven't stopped anything. It'll just go to the minimum value of our integers. We'll get an overflow error in our integer, and it will go to the maximum value of an integer and continue down again at a long pace, or basically at infinity. So we'll have an error there. So let's take a look at how we stop this. Well, we want to stop this at 0. 0 is a good stopping place for us. So let's put in an if statement. So if our n is bigger than 0, make a nice greater than there. If our n is bigger than 0, then go ahead and call recur again. So now we have something that will stop. It will only call recur when n is larger than 0. Now let's go ahead and trace this. We're going to use a new kind of tracing. And our new kind of tracing is going to look like this. We can't use our standard t-trace. We're now going to have to use a stack trace. So our stack trace is going to build from the bottom as we stack up. And once we've built our stack, we'll read from the top of the stack back down. So let's take a look at our stack trace. We have n, and we're also going to track our output. So let's say later on in our code, we make a method call of recur of 3. Well, what happens? So when we have recur of 3, we pass in 3, and n now becomes 3. So in our stack trace, we're going to go ahead and put a value of 3 for n. And just for our own recollection, we're also going to call what series of recur we're on. So we're calling recur of 3 here. This is our original call. Now, we're going to check, is n bigger than 0? We're going to do line-by-line code trace here. If n is bigger than 0, then we're going to call recur of n minus 1. So as we go through, n minus 1, 3 is bigger than 0, so we do go on. Recur of n minus 1. N minus 1 becomes our new n, and now we pass 2. Now notice, in my normal stack traces, I would cross out these numbers as I use them, but I haven't used them yet because we're stuck in these top calls so far. So this becomes 2, and we're on recur of 2. Okay, so now we check our n of 2. N of 2 is 2 bigger than 0. Yes, I make a new recur call of 1. I pass in 1, n now is 1, so I have another n of 1. Is 1 greater than 0? Yes, 1 is greater than 0. So now I get to pass in a recur of 0. I call recur of 0 as n minus 1. 1 minus 1 is 0. And I now have an n of 0. Is 0 bigger than 0? No. We check. Is 0 bigger than 0? No, 0 is not bigger than 0. So finally, I now can get to my system.out.println. So my system.out.println runs on the top level of my stack trace. So when we're reading the stack trace, once we get to our stopping condition, this is our base case. Right? So I've reached my base case. I've reached my base case. I have filled my stack as high as I can go. Now I'm going to read my stack from top to bottom. This is how Java does it in memory. It fills this stack, and once it gets to a place where it has stopped, it has reached a base case, it goes back down the stack as it completes each of the methods. That's why we call it a stack overflow, because this stack gets too big. So recur 0, we now get to the next line of system.out.println. So recur 0 moves on. So all of these have basically stopped at our n minus 1. So recur 0 now runs on 0. At n equals 0, it moves on, and it's going to print out 0. Recur of 0 is now done. It reaches the end of its life cycle as a method, and it goes away. Now recur 1 is the next thing on the stack. Recur 1 was stuck here at this statement. This statement finishes of recur of n minus 1, and it moves on to system.out.println. It uses system.out.println. It sees a 1 as n, so it prints out a 1 and a space. This is now done as it reaches the end of its life cycle as a method, and Java moves on to the next one in the stack. It sees a 2 as n, system.out.print, so we print out a 2. That one is now done as it reaches the end of the method call and the method logic, and we get on to 3, 0, 1, 2, and 3. This is how we do a simple stack trace in a recursive method. The next lesson we'll talk about using return types within our recursive methods and how we can begin to use them as a tool for searching and sorting. That's it for this lesson. Thanks for watching. Of course, there's a repl.it example down below and the PDF notes. Thanks so much for watching.